Hello everyone, this is Group 4 of AHO speaking. I want to share with you this fascinating science project we did. So here you go. Our group came up with this topic a month ago, scrolling to YouTube shorts that played music by hitting glass cups. Waves that we learned in this semester came up to our minds, and we decided, hey, why not find out what is the relationship between the amount of liquid in a cup and sound frequency. So we did a round of research, and the result told us that, first, frequency in physics is the number of waves that pass through a fixed point in a unit of time. Second, a sound wave is introduced in a medium by a vibrating object that could be the vocal cords of a person, notes, and music we make. After knowing this, we came up with our hypothesis. If the amount of water increased in the same cup, then the sound frequency when the cup is hit will be lower because the water will be more massive and require more energy to travel through. But before we start planning our experiment, we need to find an expert to make sure our understanding of frequency and wave transfer was right. So we went to Mr. Fan. Thanks again for helping us. One of us texted him and asked him about our hypothesis. After he read our hypothesis, he agreed to our points, which made us really excited to run the experiment and check it out by ourselves.
Throughout this experiment, we've learned that as the number of water increases, the pitch and frequency decreases as it needs more energy to travel through the medium. Our experiment effectively proves that the sound waves would be affected by the amount of solution in the container. But there's one limitation of our experiment. Our data might not be that accurate since we're not in a quiet environment, as we can see in the footage that we've recorded during the experiment. We placed an analyzer exactly 5 centimeters from the glassware. We then collected plastic chopsticks with the glass, and the frequency changed as the water begins to fill the glassware. The pitch, the frequency drops. This can prove that our theory is correct, but one point to improve is the noisy background that causes unwanted sound waves to also be picked up by the sound analyzer. And this could cause the data we collected somewhat unreliable. What we did to improve on is by selecting different frequency analyzers to get a more suitable result for our experiment. As you can see from the footage we've managed to capture during the experiment, we can see that we followed these steps during our experiment. We have a total of 3 drills in our experiment to make sure our data is reliable as possible. When we first test with 0 ml, then 45 ml, then 90, then 135, and 180. You can see we'd always add 45 ml each time because 180 was the maximum size of our 1 cup. We then collide the plastic chopstick with the glass cup in these 3 trails. We then gather our data and conclude an average frequency of our experiment. Thanks.
We hypothesized that if the amount of water increases, the sound frequency when the cup is hit will be lower because the water will be more massive and require more energy to travel through. We have learned from our experiment how the frequency of sound waves traveling through a container can be influenced by the volume of the liquid inside, the frequency decreasing as the amount the container holds increases. In future experiments, we would like to test how different liquids may affect the outcome, since water was the only solution we tested. We want to know if different substances that make up various liquids may also influence the results. The results of our experiment may encourage people working with radio and signal waves to consider more about how waves are transferred through long distances, choosing different locations or equipment to set up. The relationship between waves' frequency and the medium they travel through can also be seen from many applications. For example, whales and dolphins use echolocation to send out waves that travel through the water and reflect on objects or animals, and receiving these reflected waves to communicate and learn about their surroundings. That is all from Group 4. Thank you for listening.